hello everyone for these tutorial sessions about automated developer onboarding on the SUSE Rancher Prime using GitLab, Keycloak, and Rancher Fleet. Here is the plan for the today lab-based tutorial. So it's a tutorial. First, I will introduce the context and the objective for this tutorial. Next, I will cover the key concept, the role involved, and how the lab environment is organized. Afterwards, I will take a look at architecture that support the setup, followed by a deep dive into integrating GitLab, Keycloak, and Rancher. And then I will walk through creating accounts, projects, and show how to deploy the resources using Rancher Fleet. From there, I will provide a full demonstration, share some experiences and best practices, and wrap up with a concluding summary. So, are you ready? So let's get started. So first of all, I will introduce myself. I'm Stefan Estegracias. I worked at ITQ, a SUSE partner providing innovative multi-cloud solutions and advanced on-prem infrastructure, where I serve as a cloud-native innovation lead. So I'm dedicated to connecting organization, people, and the cloud-native platform, bridging the gap between the technical potential and the business strategy to drive more cloud-native adoptions. Then from the community, I serve as well as a CNCF ambassador. If you like to connect, feel free to connect on my handle Sestegra or scan this QR code. So let's start. Let's move on first on the product, personas, and organization. So for this training, let's assume we have a fictive company named Fruit Salad, so a microservice company that develop a product. Then we need 3 developers for this to create the code and 1 platform engineer to managing the record platform for develop, test, and deploying the microservices. So in that company, we have Alice. Alice is responsible for building and maintaining the Kiwi service. As is a fruit salad, we have many fruits there. Then Bob is a developer responsible for building and maintaining the grape service. And Charlie, she's the developer to develop, building, and maintaining the orange service. And to build the platform, we have Dave, the platform engineer, with oversee the environment required for developing, testing, and deploying the microservices. In summary, the organization is as follows. All microservices should run on top of the platform for the developers, and the platform will be built using Rancher and GitLab. So Dave won't build the platform manually. To onboard the developer, he will do automation. So why automation is so crucial in that environment? First, it shortens the time to productivity for the developers. Developers can start coding and deploying right away instead of struggling with manual setup. It also brings consistency and standardization across teams, presenting drift and in configuration, automating the security, reinforce the security, and then reduce the human error and ensuring the right people have the right permission. Plus, when you scale to more developer or environment, the automation makes onboarding effortless. This also paves the way for seamless continuous delivery using Rancher Fleet. And most importantly, it boosts the developer experience, offering a self-service onboarding and letting developers focus on innovation instead of setup. So let's start first by an overview of the architecture of this tutorial. So Dave deployed a Rancher manager into a local cluster with RK2. Then he deployed 3 downstream clusters, 1 for test, 1 for staging, and 1 for prod. See, remember the color for test is light gray. For staging is light green, and for prod is dark blue. And for the developer, he deployed a GitLab server where the developer will push their code for each fruit. So kiwi, grapes, and orange. In that tutorial, I will use these tools. So first, for the platform Rancher Prime, I use Rancher Manager plus RK2 downstreams, clusters, then Rancher Fleet to deploy the resources required for the developers. Then Keycloak for the identity and access management, GitLab for Git repository, and for the automation, I will use Terraform providers, so the official one for Rancher, Keycloak, and GitLab. Then, for the demo application, I use podinfo. So let's have a look on the environment right now. So here we have the dev environment. It's a Rancher Prime here with all the 3 clusters. We don't have yet any user on the platform. Neither no continuous delivery yet, and from the user, only Dave is here. He has access as well to Keycloak and GitLab, and is only him inside the user list. On the other hand, I have a similar environment for the Kiwi service for Alice. So she didn't have access yet to GitLab or Rancher. So the goal of this tutorial is to give her access to her environment to develop Kiwi service. So let's move on back on the slides. And, okay. So now how to integrate GitLab, Keycloak, and Rancher in that tutorial. So why I need Rancher in between, I need Keycloak in between Rancher and GitLab. At the time I start this project, the customer I work for requests to get the GitLab identity used to log into Rancher. So Rancher at the time was only able to connect with Keycloak with OIDC provider. So I decided to use Keycloak as a proxy between Rancher and GitLab. So for doing so, I'm use MyLab domain in that tutorial. So Rancher MyLab for the Rancher, Keycloak MyLab for Keycloak, and GitLab MyLab for GitLab. Then for each component, I use a Terraform configuration independent. So one for GitLab, one for Keycloak, and one for Rancher to let the automation be deployed with this Terraform configuration. So let's first configure GitLab as an identity provider. So I will present you all the flow, and then I will demo it afterwards. So first, on the GitLab, we need to create a Keycloak applications to let Keycloak connect to it and fetch or gather all identity from GitLab. So to doing so, with Terraform, we add a new application. So here you have the Terraform configuration. Add a GitLab application resource and use here a name Keycloak and use the redirect URL that will be set afterwards that points to the GitLab realm endpoint. We will create the realm afterwards on GitLab. So then we use the confidentiality to true and default scopes, email, profile, and OpenID. So if you are lost in the presentation, I put a logo on top who is doing what on which component. So here, Dave is manipulating the Terraform configuration for GitLab. Then, to let Keycloak connect to these GitLab applications, I will output the application ID and secret to be used by the Keycloak Terraform configuration later. So we have now configured the Keycloak application onto GitLab. And now what we have to do is to create a client on Keycloak to connect on this Keycloak application on GitLab to let user identify to GitLab. So for doing so, we create a GitLab identity provider connecting to Keycloak application using the secrets output in the previous Terraform configuration. So first of all, I will create a realm, dedicated realm for GitLab. So I will name it GitLab. First using a Keycloak realm resources with the name GitLab. And then create this identity provider using Terraform with the OpenID connect discovery endpoint from GitLab. So GitLab has a well-known URL. Then we can get information to populate the configuration of the Keycloak client. And then we will use the data HTTP source to fetch this URL and decode this JSON data into a local value. Then we'll use the client ID and secret coming from the output of GitLab using here the data source. and set as well the client identity and secret as a local value. And now we will create this identity provider using Terraform with the Keycloak YDC identity provider resource, setting their name, the real name, and then the display name, so here GitLab. Then set the client ID and secret from the local value that had been read from the data source from the output of GitLab. Then configure all the URL and configuration for OIDC connection between Keycloak and GitLab, coming from the well-known OpenID endpoint connection from GitLab. And then override the default values to set the default scope at the same list as the Keycloak application created before. So now we have this connection done, GitLab identity provider connected to Keycloak application on GitLab. So that means the Keycloak user can log into GitLab to be identified on Keycloak and on the specific realm GitLab. So now let's create a Rancher Manager client inside Keycloak. Here, this Rancher client will use the same realm, so it will use the same user database on Keycloak to let Rancher connect on Keycloak users, then on the GitLab users. So to do so, let's create the client using Terraform, using a Keycloak OpenID client resource. We use the same realm as before, we created in the previous slides. Then set the access type and standard flow at enable, and then use the redirection URL from Rancher with all Rancher MyLabs possible URL. Then, as we did before, we will output the secret ID coming from this Rancher client in Keycloak to let Rancher connect to that identity provider to authenticate, to do the authentication. So let's output it for the Rancher configuration. So now it's configured. We have both Rancher client and GitLab IDP into Keycloak. So now let's configure Rancher. To configure Rancher, we'll create a Keycloak IDP using OIDC connection to connect to the Rancher client inside Keycloak. For doing so, we cannot use Terraform, unfortunately, because there is no implementation for this OIDC Keycloak provider. But you need only to do ounce, and it's straightforward, just a few clicks away. So go to the user and authentication panel, click on Auth and Provider menu, and then select the tile Keycloak OIDC. And then configure the Keycloak OIDC account by copy-pasting the secret you get from the output of the Keycloak Rancher client from the previous slide. Then configure the Keycloak URL, so Keycloak MyLab and the realm GitLab. And here, pay attention of that. If you use a recent version of Keycloak, the Keycloak endpoint changed, if I remember well, at Keycloak 22. And here we need to click specify to remove the /auth prefix in the given URL by Rancher. Then, as soon as the connection is done between Rancher and Keycloak, you have to select the level of connection you want in your Rancher platform. Here, I select the second one. That means that the user will be allowed to connect to Rancher only if they have access to a project or a resource inside Rancher. Otherwise, even if they have an account on Rancher, they won't be allowed to connect on Rancher. So we have all the flow now for the identity management. And then we'll demo it now with the Dave environment. So Dave has a terminal here. I will launch a script that will launch Terraform behind. So all the commands you will see here are only Terraform commands to apply the configuration I just showed you. So for convenience for the demo here, I encapsulate this script into a just file. So let's start with the first flow. So create the GitLab application. So here you see the GitLab application is going to be created with all the configuration I set in the slides. So with the default scope, so type yes to apply. Then create the GitLab identity provider into Keycloak and the realm GitLab. So let's have a look here. So we create the realm, GitLab realm, with the name, blah, blah, where is it, here. So here is the realm, and here we have the OIDC identity provider setup with all the information from GitLab and URL, if you remember, the GitLab well-known endpoint to get the OIDC configuration, and all the configuration are set there with the scope as well, OpenID, email, profile. So let's type yes to apply them. So now we have the second block on Keycloak created. Now we have to create the Rancher client on Keycloak on the same realm to let Rancher connect on it afterwards. So you see for here the Terraform command line here that are applied. And here we see the OpenID client with all the information I already presented you before with the Rancher URL redirection. So let's apply it. And we'll output the secret to be used by Rancher with the configuration of Rancher. And because we cannot configure Rancher automatically with Terraform, here for the demo, I output all this value to copy-paste on the Rancher UI. So let's go to the Rancher UI. So here I'm with Dave environment, so the platform engineer. He will go to Out Provider, click on Keycloak OIDC tile, and fill up all the information here. So first, the client ID, copy, paste the client secret, then the realm, here, then the Keycloak MyLab URL. And if you remember what I mentioned before, here you see there is a /out prefix in the URL, and because I'm using a recent version of Keycloak, I have to click here, specify, to let this URL be edited by myself. So remove /out prefix here and here, and click enable. So now we'll see the login flow happens. So because I connected Rancher with Keycloak, I get the Keycloak authentication pop-up. I want to connect with GitLab, so I have to click on the GitLab icon here, and I will be redirected to the GitLab authentication part. Here, because I already authenticated on GitLab as Dave, you see Dave connection. So it take care. If you connect this account to Rancher, this user will become admin on Rancher. So here is correct because Dave is a platform engineer and is already admin on Rancher. So let's continue. And if demo goes with us, yes. So then we have to fill more information. So because he's admin, let's see, root as his name. And now the configuration is done. And as mentioned before, I will select the second option here to let users only connect to Rancher when they have projects available on the Rancher platform. So then click Save. So if we have a look on other parts, so here the configuration is done in Rancher. On Keycloak, you see the GitLab realm appear, and the client here, Rancher client, with all the configuration I set with Terraform. And to connect from Keycloak to to GitLab, the identity provider, that is here, GitLab. So with all the parameters I set into Terraform. And in GitLab, if I go to application, so admin, application, I see here the Keycloak application that serves as identity provider for Keycloak. So we have all the flow here running from Rancher to GitLab, going through first Rancher connecting to the Rancher client and the same realm as GitLab IDP that connect on GitLab. Then the dev account is linked now from Rancher to GitLab directly. So what does it mean now? If Dave has to log in into Rancher, he can select either YDC connection or local connection. If he selects YDC, he goes through all the login workflow, click on GitLab, and then authenticate in GitLab. And then GitLab will redirect to Keycloak, and Keycloak will redirect to Rancher to get access to Rancher. So now we have the configuration for the flow created. So now let's create the account and the project for the developers. So first, the account creation. So we'll do account creation for all components here to let the same chain as Dev already has to connect the developer from GitLab to Rancher. So to do so, first, I will define a user file on the HCL definition. That is straightforward, a list of users with their characteristic, so their name, email, and username. Then use this user to create the GitLab account inside GitLab. Then create this by using GitLab user resource. We use the GitLab resource looping into these users to create the resource and output these users to get the IDs of GitLab for Keycloak later on. So account created on GitLab, the same for Keycloak. So create the Keycloak account there. We use, first, we have to map the user from GitLab to Keycloak. So we create a user profile in the GitLab realm that map the property user, username, email, and user to map the database from GitLab to Keycloak. And now we will loop on all the users coming from the output of GitLab to set the resources on Keycloak user resources and loop over them, and create the configuration with all the parameters, name, username, email, and link the Keycloak and GitLab configuration by using federation here, by setting your user ID and username from the GitLab IDP, using the ID and the username from GitLab. Like this, with this configuration, you connect the account on GitLab to the account on Keycloak into GitLab. Then, as the same we did for GitLab, we output the user list from Keycloak to let the Keycloak ID available for the configuration of Rancher account. So let's move on the Rancher account configuration. We have here the creation of the account into Rancher to connect on Keycloak. So to do so, we'll get the user from Keycloak and enrich the user configuration by setting the Keycloak user ID. So extract the ID into Keycloak database of this user and link with the Rancher username we would like to use. Here the username directly Alice, Bob, and Charlie. And for the Rancher username, you need to prefix it with u-keycloak- to let Rancher recognize this account as a Keycloak user. Then we'll create the Rancher user using a kubectl manifest, using the user resources from management.io. You see here the name of the user and the configuration that link Keycloak with the ID we created just a slide before, and then the name we would like to use. So let's see now the demo of this. So yes, I did it. So it's the same here. I will launch all the Terraform apply required for the configuration. So first, create the GitLab users. So it's straightforward, 3 users to create on GitLab. Click yes, apply. Then here we create the Keycloak user. So here Alice, Bob, and Charlie with all the parameters. No, first here is the user profile mapping, so to link the attributes between GitLab and Keycloak. Then we have here the GitLab user Alice setting her username and ID from GitLab, and the same for Bob and the same for Charlie. Here the federation is done here with their ID coming from GitLab. And then we output the result to let Keycloak Rancher use this ID to set their user inside Rancher database. So let's click apply. So now we will create Rancher account. So here I see all the 3 accounts, Alice, Bob, and Charlie. For instance, here for Alice, you see her name here. And here the ID coming from Keycloak, here. And his username with u-keycloak as a prefix to let Rancher recognize this user as a Keycloak account. So let's apply with yes. And if everything goes going well, you will see here in GitLab admin users, all 3 users created. On Keycloak, the same, Alice, Bob, and Charlie. And on Rancher, you see here the users are now Alice, Bob, and Charlie coming from Keycloak provider. So that means if I try to let here Alice, so I'm here with the Alice environment, try to connect on GitLab, she will have access. Great. And Rancher, she would like to have access, so refresh here to get the OIDC connections. See, I try to connect here. Because I didn't create any resources on Rancher, she won't be allowed to connect. So let's try. Follow the flow here from GitLab, authorize the connection from Keycloak to GitLab, and then you are not allowed to connect because she doesn't have any resource on Rancher yet. So let's do it. So the accounts are linked, and let's create the project. We will create the project first on GitLab, then on all downstream clusters, test, staging, and prod, to let the developers connect on the respective configuration to give them access to their workload in specific clusters. To do so, as we did for user, we create a project definition file that lists all the projects, so Kiwi, Grapes, and Orange. For each of them, there is a part for the GitLab configuration that set the name of the project, where the project is set into the GitLab project hierarchy, and what is the access level for this developer. So here, Charlie for Orange service. Then, the other part of the configuration, we will link the Rancher configuration to that user. So here, Charlie will be allowed to connect on test, staging, and prod clusters on the dedicated namespace, fruit salad orange. And by using this project configuration, in the later slides, I will need some transformation for these input files to let the Terraform configuration use the information that are set in that input file. So first, I will need the transformation to get the list of the project, or the set for the project, to get our unique list of projects in that list. Then I will need to get the project membership to create the membership for every project on every users. So we'll transform this by using cross references to get a map of all tuple project name and username. Then the same for project by cluster. We will need this to create the project on every downstream clusters. So we'll use the same transformation to get the map listing the tuple cluster and project for every configuration in the user in the project input file. And then we need as well namespace by project to create the namespace on every project. So it's similar to what we did before. We transform the input file to a map that lists the tuple project and namespace per clusters. And then we need the other end, cluster by namespace, to let the configuration of fleet to target the cluster by namespace. So we'll do the same here. We use the input file from the project to create a map listing the tuple project, namespace, and clusters to let the fleet to target these clusters later on. So is the for loop, embedded for loop. You will see the code later. And then, finally, a user by project. We need this list of users to create the dedicated membership on Rancher. So the same, from the input project, we'll get a map with a tuple project and user per downstream clusters. So we create the Rancher project, and now we'll use, we have this project definition files and all the transformation we require. So let's configure the GitLab project first and the membership. So we'll create Kiwi, Grapes, and Orange projects using Terraform in the GitLab group. We'll gather the GitLab groups that are configured into the project definition file to have the ID of the group to set the project, the GitLab project into it. And then create the project using the GitLab project resource and loop over the project map I presented before, and set the namespace ID as the group it belongs to. So now we have the project created. We need to use the project membership loop transformation there to loop over it to create the membership of resources to let Alice get access to Kiwi project and Bob to Grapes project and Charlie to Orange project. So we loop over it to create this relationship between the project ID and the user ID. So let's have a look here on Dev environment to create the GitLab project. So let's have a look. Here we have all the three projects. So first, Grapes. Here we have all information, the name of the project, and all information I set, and will be created by Terraform. The Kiwi project, Orange project. So let's click yes to create them. Now let's have a look. So it's created. So if we go now on GitLab projects, we see all the three projects are being created. And if we click on Kiwi, for instance, Kiwi, the project is empty now because the developer didn't start their development yet. So let's now see how does it work. So here for Dave, he has access to all these three projects. If we see Alice, Bob, and Charlie, they will have access only to their dedicated projects. So Alice for Kiwi, Bob for Grapes, and Charlie for Orange. So only the project where they belong to. And now let's move on the Rancher project creation. So to create the Rancher project is similar to what we did with GitLab. Instead of here, I need to target all the clusters, so test, staging, and prod, to let the developer promote their development from test to production. So to do so, I will gather information from the Rancher clusters that have been deployed by Dave. So I will use the data source Rancher clusters to get the cluster ID that we'll need to create the namespace and clusters. So the lamp is going down. We are pumping too much energy. Then create the Rancher project per cluster. So here we see the map project by clusters I explained before in the double loop form that get the tuple that are required to loop over them to create the Rancher project. Here cluster ID, name, and a description I set here created by Terraform to let the end user know that it's created by Terraform. And then using the namespace by project, I will create the namespace resources on every project. So there is one namespace per project per downstream clusters. So we have 3 downstream clusters, 3 projects, so 9 namespace to create. And then get the loop from namespace by project, as I explained during the transformation slides. The same for membership. We'll let every user connect to their project to give access to their namespace. So here we have the membership per project loop, and loop over it using the project role template binding resource, and set all the value required to get every user connected to their project on every downstream cluster. So 3 clusters, 3 users, so 9 membership to create. So let's have a look here on Dave environment. So Dave will create this Rancher project. So remember, we have 3 times 3 times 3, so 27 resources to create at the end. Membership, project, and namespace for all users and namespace and downstream clusters. So let's click yes to apply them. And if everything going well, I will see here popping up on Rancher. If I go here on prod project, I see all these 3 projects created. The same here for staging, all 3 projects, and test the same. If I do the same now with Alice, she will be allowed to connect because now she has access to a project on every clusters. Here, only one, so Kiwi. The same for staging, Kiwi, and the same for test. So here, all the GitLab and Rancher project as created. All the connections are required to let the user connect on their respective projects. So if we see here, Dave has access to all projects on all clusters, and every developer has access to its respective projects on all downstream clusters. So now, let the developer develop their code and deploy their resource into the downstream clusters using Rancher Fleet. So to do so, we'll deploy all the fruit salad on every clusters. So we will first configure Fleet for this. So to configure Fleet, we need a Git repo object. So this Git repo will target all the downstream clusters and all the projects. And this project will fetch or pull the Git configuration managed by fleet.yaml configuration file. So to do so, I will configure the Git repo manifest file. We will use the cluster by namespace map, and we will loop over it to get all the Git repo created. So Git repo coming from Fleet cattle. So here we scan Git repo. We set the Git configuration from GitLab, so the main branch, and for each configuration a target namespace to let the developer only deploy the configuration in their specific namespace, and target a dedicated path starting with fleet / the name of the namespace. And the developer will need only to create the configuration fleet YAML file in that directory. And we'll target all the clusters that is configured in the project HCL file I presented you before. So let's create the Git repo now. So we use Kubernetes manifest to create the Git repo YAML file. And here, let's have a look on one of them. So here, for instance, the Kiwi in the project Kiwi. So we have the Kiwi URL here on GitLab, and all the target cluster demo, test, staging, and prod, and all the branch main and the specific folder here, repo, fruit, salad, Kiwi. So Git repo will point this repository to pull the configuration from it to deploy the application Kiwi from the cluster. And it's the same for all other clusters over there. So let's click apply with yes. So let's have a look here. In the fleet, so continuous delivery part, so I see all the 3 Git repo pointing to the 3 GitLab projects. For now, these projects are empty, so it's why fleet raised an error. So let's fill them. So there is an error, so let's configure the repository for each project. So we'll do so, I will simulate the developers and create this environment automatically. So I push the configuration directly, and if I go back here on GitLab, we refresh this, I see the Kiwi configuration is filled with the specific project folder here, fleet, Kiwi, fruit salad Kiwi. So repositories are then created. So now Alice, the developer of Kiwi service, can created the fleet YAML file configurations. The fleet YAML file configuration use the YAML overlay from fleet and target all 3 clusters, and specific overlay on the specific folder will target the specific clusters. So test for test, staging for staging, and prod for prod. So here I see YAML overlay, and in the directory structure from Alice project, you see at the root directory the YAML file, and overlay directory pointed from the YAML file I present you, and she deploy a deployment containing the pod info and the service to expose this pod info application. She use a deployment patch to set different value for replicas, and for the ingress, she creates a specific file per environment to get a specific URL, so Kiwi test, Kiwi staging, and Kiwi my labs for every environment. So let's have a look on how does it work. So let's see here, because they were empty, I have to force the update for every project. And if I follow the synchronization on the Kiwi project, I see all the bundle starting and the resource deployed on every clusters. Let's wait everything ready. In the meantime, I will check the test ingress. So here is the test ingress URL. I have external DNS configured in the cluster, so we need to wait a bit. The DNS propagation are down. Let's wait. In the meantime, I will expose all URL there. So here you have the test Kiwi configuration. So light gray, so is test clusters. Then the staging with staging, and prod with dark blue for Kiwi. Thank you. So now she's happy, and you are happy as well that the demo works, because Kiwi service tests, Kiwi staging and Kiwi prod are ready to work. So she has only to now to develop what they want and commit in the specific environment to test what they have to test, and then promote the configuration from test to production as soon as she's ready to deploy in production. Bob will do the same. Use a fleet YAML file, but here instead of using YAML overlay, he use customize. So it's similar configuration, but instead of using YAML overlay, he use customize, targeting all 3 clusters. He used the similar configuration, but here with the base configuration, starting with the deployment, ingress, and service that are the base configuration. And on every overlay, there is customization to let patch the number of replica, and for ingress as well, the URL regarding the target namespace, target cluster, here, grapes, test, and staging MyLab. So we will do the same, so it works as a similar. So Bob is happy as well. All of them are running. So let's have a look if it's work really. Yes, so test, grep, staging, and prod. Great. And Charlie, for the Orange service, she decided to use Helm. So for Helm, they create a Helm chart, we'll see later. And to value the Helm chart per cluster, she decided to have 2 values for the replica and for the URL. So the hostname is different per environment. So with Orange test, Orange staging, and Orange MyLab. And then here you have the chart configuration with fleet YAML. And in the chart, the deployment is like this to get the replica value I set in the value file. And then for ingress, set the hostname directly from the value file. As a result, we have all the range service running as expected for Charlie. So let's have a look. Yes, it works for testing, staging, and prod. Amazing, so it works. So here we have food salad service deployed for every clusters. And now the developers are only, the only job they have to do to connect to GitLab, code what they have to do. As soon as they push something on the fleet fruit salad Kiwi, for instance, directory, they target the configuration regarding test, staging, and prod, and fleet will automatically deploy the updates for them. And they just have to connect on Rancher using their own identity from GitLab to connect on Rancher to get access to their configuration. So now, let's assume we have someone else coming into the project. So here is Yves, he's a developer intern. So it seems quite a bit stressed. So let's have him less stressed by onboarding himself directly, automatically in the configuration. So here I have the same configuration as Alice, but for Yves. For now, he doesn't have access to Rancher or GitLab. So let's configure it. So what Dave has to do, just add the user in the user list. So here, Yves, and then add a new project in the project list, setting that Yves will deploy the Mongo service for the GitLab configuration, and for Rancher, the security team doesn't allow him to get access to the production server, so he have access only to test and staging in the dedicated namespace fruit salad Mongo. So let's have a look how does it goes on the Dave environment. So here I'll automate everything. So it's exactly the same step I presented before, but here I add a user, and the user will automatically get access to the environment. So if I go through GitLab, let's connect to Yves. Yves have access to his project. He populates the project as others. And if he tries to connect on GitLab, on Rancher, he has access only to test and staging clusters and not production, but he has access for each of them to the project that are created. So let's see if it's working well. So here I'm waiting for the DNS working. Let's wait a bit more. Let's see if it goes. No, it's not there. Too much configuration here. So Mongo up. So let's see. Cross finger. Yeah, please, DNS. Oh, now it's better. Hello. Oh, this is the staging one and test one. And if I try to load the production one, because we don't define the production clusters in the project file, we don't have any application on production as expected. So we can do the same to offboard him with the same script. We just have to remove him from the list, and it will automatically be removed from the configuration. So let's see what works well in this project for me and what challenge I faced during this project. So in the platform side, the platform engineer with this automation has more time to do more job around capabilities. So he has time to deploy external DNS, external secret operator, cloud native pages, some stuff like that. Then something need to take into account that the automation of the creation of the user need to be automated. Don't let user connect on GitLab, on Keycloak and Rancher, create this user directly to let all the flow configured automatically. Then the Git repo configuration is set by default to 15 seconds to pull from the Rancher fleet. If you grow the number of projects, I suggest to use the web hook for the commit notification and increase the latency for the pooling to don't let your cluster overload it. On the developer side, there is a learning curve on the continuous delivery using Rancher Fleet, so they need to understand how to use the YAML file, the Fleet YAML file. So the platform engineer need to train them to do so. And for improving and extending the solution, so for the platform, allow the developer to get access to continuous delivery dashboard to let them know if their synchronization are done or not. Give them some documentation to understand how to use YAML overlay, Kubernetes, customized overlay, and mchart. And for the developer experience, develop a self-service portal, test the YAML, customize, and mchart, mfleet during the GitLab CI, during the merge requests merge, so using the dedicated CLI for that. And then, to enhance the developer experience, you can use Coder workspace to let user code directly in the specific dev container, for instance. And I did since the keynote of Wednesday, use the DevX validated design to enhance this solution. So as a conclusion, as a takeaway, we create this automation using two input files, the user definition that lists the users, so straightforward configuration for the users. The same for listing the project and the permission for the project for every developers and every application on target the specific clusters. And like that, we can automate the account creation on Rancher, Keycloak, and GitLab, then automate the creation of GitLab and Rancher projects directly using Terraform, and then let the continuous delivery using Fleet target every Kubernetes downstream clusters, and let pull the configuration from Fleet YAML from GitLab. Thank you very much for your attention.